don't have your 3 bonus points for typos, submit. New version of question 4 on page 27. That's all you have to write. So the idea behind this is that there's a claim involved, and we want to see whether or not that claim is going to make sense. All right. So we'll set it up. The factor part of it, the keyword factor there, gives us a sense of multiplication. All right. Whenever we're talking about multiplication, we're talking about an exponential relationship. All right. So we're not worried about a linear relationship. That being said, all of these word problems were exponential to begin with. All right. The decrease part is exponential decay. We're starting off with 924 students. So y of t is going to be 924, 1 minus 1.045 to the t power. All right. So very simple setup, but there's actually a substantial flaw in the claim. All right. But we'll get to that in a second. When they say how many will graduate in 2024, we're not going to put in 2024 for t. We're just going to put in the years since 2009. So we're going to do 2024 minus 2009, which is 2015. Not 2015, 15. All right. So we're looking for y of 15. Now, if you just run the straight computation, you'll get a number. And you might look at that number and say, oh, I guess it makes sense. But you got to be careful about it. I'll show you. So you put in your function. And you could type it in manually, but I want to show you what the table is going to look like. All right. And if you go to the table and ignore every value except for the one at 15, you'd get something. You know, negative 6e negative 18. I mean, should talk about scientific notation somewhere along the way. What that would be is negative 5.806, roughly, times 10 to the negative 18th power. All right. Now, in terms of whether this scenario makes any sense, different story. First off, I'm seeing some negative numbers here. I'm seeing some positive numbers too, but the fact that there's some negative outcomes here, it's alarming. So you think to yourself, how could you have a negative student? All right, you could kind of go the philosophical route and come up with an answer. But the more important piece here is that we're looking at a decrease of 1.045. All right, so this doesn't make sense. Does not make sense because the decrease is more than 100%. All right. So in theory, you wouldn't really have to do the computations, but I did want to show you what the outcome would look like. All right. That 1.045, remember, when we look at the numerical values in the parentheses, every one of those decimal values is really the decimal form of a percent. So when I look at the 1 minus, I'm taking 1 as 100%, and I'm taking a percentage away from that or adding a percentage to that if it's growth. So here I'm taking 100% and removing more than 100% from it. So that's saying I'm taking more than all of what I have away. All right, so if I had 100 marbles, this would be saying take 100 and, well, I'll round it, 105 marbles from the 100 marbles. Well, where are the other 5 marbles coming from? There aren't any marbles. So after the first year, you wouldn't have any more marbles to work with, in this case, students. All right. So all 924 students are gone. They haven't been replaced. So how do we decrease further from that? We don't. That's why we get some negative values. All right. So I took a flawed question, kept it flawed, but for a purpose. All right. The next one, number 5, 2017. A research company found that smartphone shipments, units sold, were up 32.7% worldwide from 2016, with an expectation for the trend to continue. If 959 million units were sold in 2017, how many smartphones can be expected to be sold in 2022 at the same growth rate? All right, so a much more straightforward example. All right, so we're looking at y of t is equal to, we have 959. Got to be careful about units here. So it's in millions of units. So if I get an answer of, let's say, well, it's going to be bigger. So let's say 1,200. I have to understand that it's 1,200 million, all right, units. So the rate of growth would be 32.7%. So 1 plus 0.327 to the t power. We want to know what's going on in 2022, all right, based off of what has happened in 2017. So 2022 minus 2017 is going to be a result of 5. So I'm looking for y of 5. So some number crunching. You do it manually. Honestly, these problems take a little longer than some of the ones we've done in the past, only because you have to do the calculator work. I mean, if you somehow came up with like a 2 as your base value for the exponential, then maybe you could do it in your head, but that's pretty rare. Right? I'll do it with the alpha trace technique this time. Alpha trace y1, pop in the 5, and so we get this number here. All right, 3946.14666. Got to be careful about rounding here, right? Because it's in millions of units. All right, let me show you the difference between a rounded answer and an unrounded answer. All right, so if I leave it like this would be the equivalent to moving the decimal place over 6 times. So 3946146656 units. All right. So that's 3,946,146,656. All right. If we rounded, let's say we even rounded it to 3 significant digits, 3946.147 million units. That would be 3946147000. 3,946,147,000. All right. So a difference of 344 units. All right. So we would have lost a fairly substantial amount of accuracy. All right. So in the case where the units are large, we want to make sure that we don't round until after we do the unit conversion. All right. If after we convert from millions of units to just plain units, you still get a decimal value and you want to round that, just be careful about how you round it, but that would be okay. Don't round it before you do the unit conversion. All right. Now, that brings us to compound interest, which is actually not going to be very complicated in comparison, because we're only going to focus on the one type of compound interest. You'll do more with this in Algebra 2, because we're focusing on compounding interest on an annual basis. And just generally, what compound interest it boils down to is you earn interest on the amount of money that you have invested over a period of time. And at the end of that period of time, that money is awarded to you. It's included in your account. And now you earn interest on not only the initial investment, the amount of money that you deposited initially, but the interest that you earned in the first period. All right, so let's say you put in $500 in a savings account over the first year, and you earned, I'll say 1% interest over the course of that year. So you have $5 in interest after that first year. So now for the second year, you're going to earn interest on $505. All right, so you'll have $5.50 worth of interest. All right, so a little bit more. Right, which gets added on after the second year. You now have $510.50 to earn interest on. All right, so it keeps compounding that way. You're not only earning interest on the initial investment, but you're earning interest on the interest. So that's the compounding part. All right, so that's basically what the blurb is talking about here. But compound interest uses the same function as exponential growth, but t is always represented by years, time in years. All right. So that's the one adjustment. We don't have to worry about the units of time because it's always going to be in years. All right. So these examples aren't really going to be any different than what we were doing, because I'm going to say y of t is equal to, we have $500 to invest, 1 plus 6%, so 0.06, compounded annually. That's the key word there, because when you get to the higher levels, they're going to say compounded monthly or compounded daily or compounded weekly, because the period of time in which you can earn interest can vary. All right, so like I said, you might earn interest over the course of 1 year, but maybe you earn interest over the course of 1 month, and you're awarded that interest after that 1 month period. But we're only focusing on annually. All right, now they say how much will Ben have after 6 months. Because time is in years, we have to let t be equal to 1/2. All right. And so 1/2 of a year. All right. So we're looking for y of 1/2. And then we also have to let t be equal to 5. So y of 5. So calculator work. This is where the table might let you down a little bit. So I put in the 500, 1 plus 0.06 raised to the t power or x power. If I go to the table, I can get the answer for 5, but I'm not going to get the answer to 1/2. So you get what you get. So I'll take the 5. So this would be 669.112788, which would round. They didn't tell us rounding instructions, so we'll just take it upon ourselves. We'll say $669.11. But I don't have the 1/2 here. So I'm going to quit out of here. I'm going to do the alpha trace. Alpha trace y1. I'm going to pop in the 1/2. So $514. Now, most of us are not really at the point where we're overly familiar with what interest rates are nowadays, but if you are, you might recognize 6% as being an absurdly high interest rate. The actual interest rates nowadays are closer to 1%. All right, so if you have an account that's bearing 6% interest, assume they are doing something illegal. And that, well, you're probably going to go to jail. What's that?
If it's 6%, wouldn't that benefit me?
It would, unless
it's not illegal if no one says anything.
Except they always get caught.
Okay, then that's a problem.
Yeah. It's the, if you're not familiar, look up Bernie Madoff.
Aren't inflation rates also, aren't, what's it called, interest rates adjusted to match the rate of inflation?
Yeah, but it's an inverse relationship.
Like, you're not earning more money than you did before, you're just earning, well, what do you mean inverse relationship?
So as one goes up, the other goes down.
Yeah.
Yeah. So what they'll do to correct for inflation is they're going to increase the interest rate, and that should help bring down inflation. All right, but they're very slow to make that adjustment. So I think there was talk in the Fed about bringing up the interest rates by about 0.5%. So it's very slow moving in that front, because if they make too much of a move too quickly, it could have catastrophic effects on the economy.
Why would that be like hyperinflation?
What's that?
Would that be hyperinflation?
It honestly, that part of the theory I'm not sure about, but that sounds right. That just means I got to talk to Mr. Rosenzweig or Mr. Guarini during my free period and get that answer. Right. So Ava plans to put her graduation money into an account and leave it there for 4 years while she goes to college. She receives $750 in graduation money that she puts into an account to earn 4.25% interest compounded annually. How much will be in Ava's account at the end of 4 years? All right. So because they gave the units of time in years, this is a very simple problem. Y of t, starting off with $750, 1 plus 0.0425 to the t power, and we're just evaluating it for when t is equal to 4. And since it's only one computation, you may consider just typing it in straight away. All right, so we have 885. And these are, honestly, I sort of question why this topic is in the curriculum, because we barely scratched the surface on it, not enough to really draw any meaningful conclusions. Because you kind of look at it and say, well, this is only one instance of compound interest. What about cases where a person invests $750 every single month over the course of 10 years? How will that money grow? You know, this is just, you put it in an account and just leave it there for 4 years. Right? Okay, that's one very specific example. It's useful information, but you won't really travel down this road too far until you get to Algebra 2. All right. So at long last, that's it for the lesson. So your practice is the next page.